All right, so we've talked about the types of waves based on how the individual particles oscillate or move back and forth in the medium, compression and transverse. Now we need to talk about types of waves based on how the wave travels, the mode of wave propagation. And the first type of wave in that category is called a mechanical wave. Mechanical waves require matter as a propagation medium. They have to move through stuff. They have to move through matter, and that's any matter, anything whatsoever. Air, soil, water, concrete. Waves can go through all kinds of these things, and those waves are called mechanical waves because they have to have stuff in the medium. They have to have molecules, matter, particulate matter, particles to move, which means they cannot, conversely, they cannot travel through a vacuum. And remember, a vacuum is not what you clean the floor with. It's a place where there is no matter, including air. And the reason they can't travel through a vacuum is because they actually use the particles of the medium in order to propagate themselves, right? So here's two pictures. You can see on the left there's a transverse wave. On the right you have a compression wave. And basically with a compression wave, the way that it's mechanical, the way that it works is that particles literally bump into each other, and that particle bumps into the next one, and that particle bumps into the next one. And that's how the wave is propagated. It's just a whole bunch of particles bumping into each other. And in that case, as you can see, if there are no particles there, there's no wave. That wave doesn't get propagated because there's nothing to bump into. Same thing with the transverse wave on the left. Those particles are at least partially bonded to each other. If you think about water molecules, there's some tension in those molecules because they exert a little bit of a bond on each other. But if this is a rope, those particles are certainly in contact and bonded to each other. It's not like you can just rip a rope apart. So when this one red molecule moves up, it pulls the next one with it and vice versa. And so that's how that wave gets propagated. But again, it's dependent on a medium. Some examples of mechanical waves. Now realize these two categories are independent of the other two categories we talked about. We talked about compression and transverse waves. Well, some compression waves are mechanical waves. Some transverse waves are as well, which is why I've shown you these two pictures. So sound is actually a compression wave. We talked about that. Has to use air or some other material for its medium. That's why you can't hear in space. You can't hear on the moon. And now you know why all those space movies that have you hear things in space, those are false. You can't hear anything in space. There's no matter. Water waves, seismic waves, slinky, rope waves. I showed you a video of the wave. In that case, you yourself are the particle. If there's no people in a stadium, the wave is not going to happen. So all of these are examples of mechanical waves. Again, these waves require matter to propagate. They cannot propagate themselves in a vacuum where there is no matter. Which brings us to the other wave. Electromagnetic waves specifically do not require matter to propagate. Now, in a way, electromagnetic waves are a very, very specific type of wave, and that's true. But the point is, these are the only kind that can travel through a vacuum. They do not need matter to propagate themselves. Again, these waves have to have matter to move. Electromagnetic waves do not need matter. Now, they can travel through matter, but by definition, they are self-propagating. They drive themselves. They move themselves, unlike a sound wave, which relies on those molecules. It's the molecules that pass the wave. Not true here. So electromagnetic waves don't use the particles of the medium to propagate. They propagate themselves. They can go through matter, and that's obvious. Right now, you're seeing this video because light is traveling from your phone or computer screen through air to your eyes, right? So it goes through a medium. Light can go through air, through water, through glass. But the particles in the medium simply get in the way and kind of slow the wave down. And I like to illustrate that in this way. Air in a vacuum versus light waves or electromagnetic waves going through a vacuum, and electromagnetic waves going through water are very similar to running it in air and then trying to wade in water. You can see the picture of the woman on the right, or the GIF of the woman on the right. That's about as fast as you can wade through water, because all of those molecules get in the way. And imagine that she is the electromagnetic wave. She is self-propagating. She's moving herself. But Forrest Gump on the left, he can run really fast because the air molecules don't really get in the way. It's kind of like EM waves through a vacuum, although I know he's not moving through a vacuum right now. But the point is, when electromagnetic waves go through matter, the particles just get in the way. Here's another GIF showing how that happens. On the left, you see a photon coming into the picture. And it first of all has to be received by the molecule and then spit back out. So that's the reason why the molecules, quote unquote, get in the way, and it takes some time. It takes more time for light to go through medium than through air. It travels slower, but it still can. But the point of all of this is that EM waves don't require matter. They can go through matter, but they don't absolutely have to have matter to go through medium. And a really good example of that is all EM waves, all electromagnetic waves. And we'll talk more about this later when we talk about light. But light itself, the stuff that you see, is an electromagnetic wave. Radio waves are electromagnetic waves. Microwaves, infrared radiation, ultraviolet, gamma rays, all of those things are electromagnetic waves and can travel through a vacuum. We know that because the light from the sun reaches our eyes through the vacuum of space. It is not a mechanical wave. It does go through the air, but it doesn't need air to propagate. And you might ask, well, how are EM waves self-propagating? Well, in short, that's a long story, probably deeper than I can go. And that's another lesson where we will talk about that. Basically, if you really want to know, it's caused by the vibration of charged particles, which produces oscillating electric and magnetic fields, and they travel at right angles to each other. So that's actually not one wave, it's two. And it's in a bundle of light energy that we call a photon. This GIF is a great way to illustrate that. But if you're looking like this person on the right now, and you're like, I don't get this, that's okay. You don't have to know that right now, okay? All I want you to know is electromagnetic waves do not require a medium, whereas mechanical waves do require matter to travel through.